Hey curious minds, welcome to Plain Techniques, where maths problems get a simple twist. In today's video, we are going to talk about trigonometry ratios. Triangles are everywhere, but did you know that they hold a secret to solving real-world problems? From calculating the height of a building to figuring out the perfect ramp angle, trigonometry ratios make it all possible. In this video, we are going to break down sine, cosine, and tangent in the easiest way possible. Let's go. Let's say you are given a triangle like this, right? This is 90 degrees and this is angle theta, right? It is very important to know how to identify all three sides, right? So I've made a video on Pythagoras theorem. I'm going to put a link somewhere on this video so you can go watch that video and you can come back and watch this one so that you can better understand what we are going to talk about today. Okay, now in that video we talk about the hypotenuse, right? Now the hypotenuse is the longest side of your triangle and it is directly opposite to 90 degrees. Directly opposite, this is what I mean. So it's directly opposite your 90 degrees. This is the 90 degrees. Okay, all right. Therefore, this side is my hypotenuse. All right. So this side will be called my hypotenuse. All right. Now, the second part is to identify which side is my opposite. You look at what you have here. The angle that you're given, it can either be here or there, right? So the side that is directly opposite the angle that you are given, right? That side is therefore called the opposite. So this is the angle that I'm given and it's opposite this side, right? Therefore, this side is now my opposite, right? That is my opposite because it's directly opposite the angle that I've been given, right? And then you know the one that is outstanding or the last one is therefore called your adjacent. Okay? So this one will be my adjacent. Okay? Now we were able to identify all three sides. Right. Let's take another example. Right? So let's say you have a triangle. I'm going to flip it like this. So let's say you have that triangle, you have 90 degrees, and you have theta there. Okay? Now, please pause the video and identify all three sides based on what you have been given here. Right? Now, let's continue. Which side is your hypotenuse? That is where you need to start. Your hypotenuse is directly opposite to 90 degrees angle, right? And it is the longest side of my triangle. Okay, so this will therefore be my hypotenuse. All right. What is the other thing that you know? This is the angle that you have been given. All right. Now it's directly opposite to this side. Directly opposite to that side. So I'm going to go ahead and put this like this. So it's directly opposite to this side, right? Therefore, this side is therefore called opposite for that reason. All right. And I have the last side, which is obviously called the adjacent. Okay. Now, let's take the last example and then we can conclude this topic. let's say you are given theta there, 90 degrees, all right? Same thing. Pause the video and let me know which side can you identify and why. Comment in the section below. All right, let's resume. What do we have? We know that we have 90 degrees and the side that is directly opposite to 90 degrees is therefore called hypotenuse. All right? And then what is the other parameter that you've been given? You know you've been given the angle. All right? Now, the side that is directly opposite that angle, right? This side will therefore be my opposite. So this side is directly opposite to the angle that I've been given. All right. So this is now my opposite. Okay. Automatically, the last side will therefore be my adjacent. Trigonometric ratios. They are used when you need to relate the angles and sides of a right-angled triangle. Here are some common scenarios. If you know one side and one angle, you can find the missing sides. And if you know two sides, you can find the missing angles. Let's say you are given a right-angled triangle like this, all right? This is 90 degrees and this is angle theta. From the previous slide, we know how to identify all three sides, right? So this will be my hypotenuse, this will be my opposite, this will be my adjacent, all right? So trigonometric ratios. So we have the first trigonometric ratio, which is sine theta, right? So whatever that I'm writing here is in relation to this triangle. It's sine theta, right? So sine theta will be opposite over hypotenuse, all right? So this is the relationship. So it's opposite over hypotenuse, okay? So the second ratio, which is cos theta, which is adjacent over hypotenuse, all right? And then the third one is tan theta, which is opposite over adjacent, all right? Now, the best way to remember these trigonometric ratios is to use a mnemonic called "Oh hell, another hour of algebra." That is funny, but that will actually help you to remember the trigonometric ratios. Okay, so let's say you are given a triangle like this, okay? So this is 30 degrees, A, B, C. This side is equals to 8, and that's all you're given. Right, the question says, determine the length of AB. This is what we want to determine, all right? So from the previous slide, we know that this is my hypotenuse, okay? This side is my adjacent, and this is my opposite, okay? I'm going to quickly put down my trigonometric ratios here. So it's sine theta, which is opposite hypotenuse. Cos will be adjacent over hypotenuse, and then tan theta will be opposite over adjacent. All right, so I put them right there. I'll tell you how to apply these things on this figure. All right. Now, we need to know which one of the three trigonometric ratios to use when you are given a figure like that, right? So, how do you choose, or how do you know which one to use, right? Obviously, we are given the angle, right? All of them, they contain the angle, all right? So, that that part has been ticked, right? Now, you need to look for another one, right? Another parameter is the hypotenuse, right? So, we can either use this or that. Why? Because they contain hypotenuse, both of them. Okay? Now, let's narrow it down to find out which one do we really need to use. All right? So, the side that we want to calculate is that opposite. Which one between these two, right, has opposite? That has the opposite, right? So, this has the opposite, right? That means we are indeed using that ratio. This is the ratio that we are going to use because it contains all the parameters that we are interested in and the parameters that will help us to calculate the missing side. All right. So I'm going to go ahead and put it down right here. Okay. So what do we actually have? We have sine. What is our angle? Our angle is 30 degrees. Okay. Now, the opposite side is AB. AB. That is our opposite side. So I'm rewriting that. So sine, and then the angle, I put 30 degrees, and then opposite is the side, which is AB. Okay? So it's AB. That side is AB. Now, divide by hypotenuse. This is hypotenuse, right? What is the value of my hypotenuse? 8. So I'm going to put 8 here. Okay? Now, to determine AB, what am I going to do? Multiply both sides by 8. Multiply both sides by 8. Okay? So AB will be 8 multiplied by sine 30 degrees. Okay? So because of these ones will cancel each other, I'll be left with AB. All right? So what do I have? I have AB. When you punch this into your calculator, what do you get? Well, I get 4. Okay? So what does it mean? This means that this side opposite is equals to 4. All right. So let's say for example number 2, right? You are given this triangle. All right. So this is P, Q, and I. That angle is 60 degrees. Okay. And we know that this is 5. That side is 5. Okay. That is 5. PQ is 5. All right. What do we know? We know that this is my hypotenuse, this is my adjacent, and this is my opposite. All right. Why? Because this is directly opposite to 90 degrees, and this is directly opposite to my angle. Okay. I'm going to go ahead, right, and put down my trigonometric ratios. What do we have? We have sine theta up over height, cos theta. What do we have? Adjacent over hypotenuse, and then tan theta. What do we have? Opposite over adjacent. All right, that is what we have. Now, the next step, right, is to look at what we are given. All right. Now, the question says determine the length of the hypotenuse, right? So check what they did here. They didn't give you, they didn't say calculate the length of PQ. They said the length of hypotenuse, meaning that you need to know which one is the hypotenuse. Okay? I like that question. Now, so determine the length of the hypotenuse on this figure. If you don't know hypotenuse, you'll calculate this one and your answer will be wrong because this is not hypotenuse. This is opposite. All right? Now, let's check what we've been given. We've been given the angle. Okay. All of them, they do have the angle, right? So what am I going to do? I'm going to say all of them qualify because they have the angle. I'm trying to narrow down on which ratio to use. Okay? Now, let's continue. So that parameter that we know has been applied there. Okay? Now, here is another parameter that we know, which is adjacent, right? Which of these three ratios contain adjacent? All right? So I see adjacent here and I see adjacent here. Okay? So what am I going to do? I'm going to put a tick here, adjacent and adjacent. All right. So you can see that already that one is eliminated. Okay? Because it does not have, it does not meet the requirements. Okay? Now, that is another parameter. Let's look at the third parameter. The third parameter is the hypotenuse. Why? Because that is what we want to calculate. Which one between these two, right, contain hypotenuse? Only that one. Only this one, right? Therefore, what this means is we will use cos, right, to solve our question. All right? Let's go. So I'm going to say cos 60 because 60 degrees is the angle that we are given here. So cos 60 equals to, now, if you check here, this is adjacent. Do we know what adjacent is? Yes, we know the value of adjacent, which is 5. Okay, I'm going to go ahead and write 5, which is the value of adjacent. But we are looking for hypotenuse. So this is hypotenuse. We don't know. I'm going to put hypotenuse here, or I can put PR. Okay? So it's up to you. So what I'm going to do is I'm going to say hypotenuse. That is what we are looking for. All right. So if I say multiply by hypotenuse both sides, all right, what I will have is I'll have hypotenuse this side cos 60, and then this side I will have 5. All right. What am I going to do here? I need to divide. Now I need to divide by cos 60. So divide by cos 60 both sides. Okay. Now hypotenuse will therefore be 5 over cos 60. What is 5 over cos 60? When you punch this on your calculator, what do you get? I get 10. All right. Now, this is my answer. All right. So if you've watched up until this far, please don't forget to subscribe and like and share my video. See you on the next one.